This video is about debugging in MATLAB, how to use the MATLAB debugging tools in the editor window. Pretty much every person who has ever done any sort of computer programming knows how frustrating it can be when code outputs errors or doesn't run the way it's expected to. So if you're having problems with your MATLAB code, don't worry. You're not alone, and there are certain steps you can take to figure out what the issue is so you can fix it. This process of identifying and removing errors from computer software is called debugging. There are a number of ways you can debug in MATLAB. Here are a few of them. The most elementary way to debug in MATLAB is to simply output your variables to the command window to see their values at any point in your code and check that these values match the values that you expect to get at that point. You can do this in a number of ways. One way is by deliberately neglecting to put a semicolon at the end of any line that acts as an assignment to that variable. Another is by using fprintf statements that print the variable to the command window. Another is by using the display keyword to display the value of that variable. Using print statements to debug is basic and simple, but if we need a more robust way to debug, MATLAB supplies a number of debugging tools in the editor window to help you debug your code. MATLAB allows us to set breakpoints in our code, for example, that will cause the program to stop running once it hits a breakpoint and allows us to see the values of every variable at that point in the code. We can also set breakpoints that only pause the execution of the program when certain conditions are held, such as pause when y equals 5 or pause when an error has occurred. To show this, let's take a look at an example function. This function is supposed to convert all the words from a string into uppercase and store each individual word into its own spot in a cell array. So this function initializes a variable called word to an empty string and then goes through the string input and concatenates every character in the string to the variable word until it hits a spot in the string that is not a letter. At that point, it signals that the word is over, stores the word in its own position in the cell array, and then resets word to an empty string. This process continues until the code has gone through every character in the string input. So let's go through and make sure that this code works right now as it is. So let's put in the example string, question mark, check adjacent elements for special patterns. So we're going to type in the function name and paste that in, put the little string symbols. And CA turns out check adjacent elements special patterns, which is what we want it to turn out to be for this function. So let's purposely mess it up by commenting out the c equals c plus 1 part here, and I'm going to write a little note saying that we are doing this on purpose. And let's run the code and see what happens when we do that. So we see that when we comment out that line and we run this function again, all that CA turns out to be is turns. And we know that that's wrong. That's not what we're expecting to see at this point. We want to see that full string with all the words in that string. And we obviously know that the reason that it's turning out like this is because we commented out that one line that increments C. But let's say this is you working on your own individual function and you're not getting what you want to get and you're frustrated. Let's try to think about some possibilities for this error and kind of mess around with breakpoints and see if we can figure out what's going on. Well, we know that there's a problem when we assign things to the cell array. So we're going to put a breakpoint at line 18, which happens right after we assign to the cell array. And we're going to run this code. And what's going to happen is it's going to stop the execution of the program right every time that it hits that line. And we're going to see all the different variables at that point. So right now we see that the word is check. And that makes sense. And the string is check adjacent elements for special patterns. The first word should be check. So that's good. That's working right. And we press continue to see what happens the next time this code gets to line 18, and it's adjacent, which is right. But we see that the cell array only has adjacent in it. So that's weird because we should have stored check first. So if something's wrong, let's run it again. Now we see it's special. So okay, now we're starting to get an idea of what's happening here. So we can stop the execution and we can say, oh yeah, right, we need to increment C. And now we can take out that breakpoint and the code will work. So let's look at another way we can use breakpoints. We can set a breakpoint in our code when a certain condition is met. So for example, if we want to pause execution of the program whenever we're at the third word, we can write C equals 3 as a breakpoint condition and then run this. And if we check the value of the CA cell array, we'll see that it has check adjacent elements as its 3 words, which is right. So now we press continue and the entire CA shows up, and we can change this to make it when we're at the 4th word. And we check CA, check adjacent elements special, and you get the idea. To remove the breakpoint, all you do is click on the line number where the little circle is. You can also go up to the breakpoints and set conditions to have your code stop when there are errors or when there are warnings in your code. Right now there are no errors, so that's just going to continue and just run through the entire code. But if there were any errors, it would stop when you hit them. So I just unclick that. Now there are no more breakpoints set. And we know that our code works, which is good. So as I showed in that example, probably the easiest way to set breakpoints in your code is by going up to the editor window in MATLAB, clicking the breakpoints tab, and then following the instructions under that tab. But you can also set breakpoints straight from the command window by writing the phrase dbstop, and there are a number of different ways you can use dbstop to set breakpoints. We can say dbstop in name, where the name is the name of the function or script, and what this will do is simply pause the execution of the program at the first line of executable code. So in this case it's line 8, and we can see there's a little red dot that's showing you that there's a breakpoint at line 8. We can also say dbstop in name at whatever line number, so dbstop in make key array at 18 will set a breakpoint at line 18, which we can see is happening here. We can also say dbstop at line number if a certain condition is held, such as if C equals 3, and we'll see that there is a yellow circle at line 18 in this case, showing that there is a conditional breakpoint at line 18. We can also write dbstop in name if error, which will set a breakpoint that pauses the execution of the program when there is an error. We can also say dbstop in name if naninf, which will stop the execution of the program whenever it returns a value that is either infinite or non-existent. So those are 5 ways we can use dbstop to set breakpoints in our code, and you can always type in the command window help dbstop if you want any more information about dbstop. So the final tip I have for debugging in MATLAB is to separate your code into sections and run each section separately. So to do this in MATLAB, you go into your editor on whatever program you're debugging and write in 2 percentage symbols. And this will cause a portion of your code to turn yellow, which is showing you that there's a separate section now. And up in the editor window, you can see that there are buttons called Run in Advance, Run Section, Advance, and this is showing you that you can run each section separately instead of running the entire program at once. So those are my main tips and tricks for debugging in MATLAB, and I hope this video was helpful.